Yo, what is up, guys? Welcome back. This is episode 149. So, sorry, just making sure everything looks good on the stream. Yo, what is up, guys? Welcome back. Okay, but yeah, we're just gonna jump straight into it. Sorry, making sure everything looks good, but looks like it does. We're gonna jump straight into it. Let's jump into our leaker problems. Check out the problem of the day. Max difference you can get from changing an integer. Let's take a look at this one. You're given an integer num. You will apply the following steps to num 2 separate times. Pick a digit. So pick a digit 0 less than x. So anywhere between 9. Pick another digit. A y. Note y can be equal to x. Replace all the occurrences of x in the decimal representation of num. Okay. Replace all occurrences of x in decimal representation of num by y. Let a be the two results from applying the operation to num independently. Return the max difference between a and b. Note that either a nor b may have any leading zeros and must be 0. So 55, 888. The first one, biggest x equals y. Y equals 9. For the new integer in b, we now have a 999 and b 111. The max difference is e is equal to 888. I feel like this is probably a similar problem to the one that we looked at yesterday. I'm a little confused with the problem though. I don't really know what it's asking me. Max difference you can get from changing an integer. Even a positive integer num, you can change at most one digit to any other digit 0 to 9 in each of the two new numbers. So the maximum difference between these two numbers. Integer num, you can change at most one digit to any other digit. One would be a minimum possible number. So the maximum difference between these two numbers. Hey, what's up, Takish? I see you, bro. How you doing today, man? To get the max number, we want to replace with 9. We're looking at like a similar problem we were looking at yesterday. I feel like this is something similar. Pick a digit. Pick another digit. Place all the occurrences in x and decimal representation of num by y. So I think we're gonna kind of look at pretty good. What about you? Yeah, bro, I'm chilling. I thought I was gonna go live a little later, but I don't know. I decided to record now. It's about like 3 p.m. here, so where I'm at, well, actually like 2:30, but getting close to 3. So I thought I'd just take a look at it now. So for char and num, want to find the max, right? So our max here would be, well, sorry, I got something in my eye, man. Oh my gosh. Char. Given an integer num, you apply the following steps to num to two separate times. Pick a digit. Pick another digit. Note y can be equal to x. Replace all occurrences of x in the decimal representation of num by y. Let a and b be the two results from applying the operation time independently. Return the max difference between a and b. I literally feel like it's like 1 a.m. So if you had done late, would have missed it. Yeah, well, probably tomorrow because I work at I work, so it's probably gonna be like probably 7 p.m. my time, so probably about 4.5 hours from now. What's up? Is this back, dude? Thanks for joining the stream, dude. What's up? Doing some lead code. Place it first. Okay. Understandable. Yeah, yeah. So I think what we're going to do here is we're going to find the max number here like what we did yesterday, right? So let's do our max num is equal to, we'll make it none for now, right? If char does not equal 9, because you don't want the first number. If the number's 9 already, then we don't want to change that, right? That wouldn't make it the max number. Are you solving in C? No, bro. This is Python. C is too complicated for me, bro. I use Python, dude. Char does not equal 9, then we want max num to be equal to char. What we want to break here, right? So we found our max num. Replace all the instances of that number here. Go for char in num. If char is equal to max num, char is equal to max num. We probably or Python. Yeah, it's Python, dude. It's Python. C is too complicated, man. I think we're gonna need to make like a an array here. So we can just make it a string. I feel like string num is equal to string num. We can go for char in string num because we can't loop through an integer. So we need to change all this to string num. Place all instances. So let's do this. We'll make string max num is equal to string num. Then we'll loop through string max num. If the char is equal to the max num, right, which is our max num up here, then we replace it. Char is equal to max num, which I think is good. And let's print our string max num just to take a look at it. .555. Output null. Why are we getting a null here? If char does not equal 9. Oh, this needs to be I think a string here. I think that's why it's not working. Nope. Why is this not working, dude? I don't know. Max num for char. If char does not equal 9, max num is equal to char, and we break. Okay, let's just check if the... I don't think this is... Print out max num. Oh, wait, shit, it is printing. What am I looking at, dude? Okay, so it is printing. So we're looping through. We're getting the char. If the char does not equal 9, we're making max num is equal to char, and we break. Okay, so now we have our max num, right? Go for char and string num. If char is equal to max num, we want to make it 9. That's what we want to do. That's what's wrong. Is that hashtag max finding the max digit? Yeah, it is. Yeah, it's finding the max digit that's not 9. So, okay, there's something wrong here again. So this is finding the max number, right? So in this problem, we're looking for It's pretty much something similar to the one we did yesterday. Yesterday was like an easy one, which actually took me like 45 minutes. But so pretty much, yeah, we're looping through, finding the max, right? That's not 9, because we want to change this into the max number, right? The reason why we want to look for a number that's not equal 9, because if our first digit is 9, then, you know, if we're replacing our first digit again with 9, we're not going to make the max number, right? So our max number would be, you know, our second spot here. I believe. If yes, and I believe the logic is incorrect. Yeah, we're trying to make the number a max number. So whatever number we have here, I think, I know there's something incorrect in here, but I think it's because I'm working with a string here, and I'm thinking I'm working with an array. I think we have to do like a dot replace or something. I think there's like a dot replace in Python or something. Dot replace Python. Substring, new substring count. Optional. I think we need to use this. String char dot replace char with 9. Is that how it works, dude? I don't know. Nope. Old substring, the old replace. What is it? I feel like we're doing something wrong here. What is wrong here? I feel like there's something. I think I'm messing up this replace function here. Creates a new string but doesn't update. Okay. That's what I'm messing up here. Okay. So we need to make string max num equal to string num dot replace char 9 to be this. Let's take a look at this now. Okay, we get 999 now. Okay, so we can get rid of this stuff. String max num is equal to string num dot replace char with 9. Does that replace string num? I want to check. I'm not sure. Let's see what this does here. Okay, no, we're fine. Okay, I'm tripping. Okay, so we've done our max now. So now, pretty much we need to do our min, right? Do the complete opposite, right? So, min. We want our min num. We can initially set it to none for char in the string num. We want to check, okay, well, if char... what would be the min? What was it yesterday, man? I barely remember. What did we do yesterday? If char... I'm just gonna take a look, to be honest. I don't remember what I did. I think it was does not equal 1, but I'm not 100% sure. I think this is a build off of the problem yesterday, which I think is this one. What did I do? Does not equal 0. Okay. Let's take that. Start with that. Char does not equal 0. Then we want our min num to be equal to char, right? And then we want to break. Then we want to replace all the instances with 1. I guess one here, it should be 9 here. 9. Right? So we make string min num to be equal to string num. We loop through our string min num. We make, if char is equal, if char is equal to min num, we want to replace every single instance. So we would go, okay, so string min num is now equal to string num dot replace our char. We want to replace it with 1, right? Because that would make our minimum. Let's print. Let's bring our string min num here. String min num. Okay, we got something wrong here. Dot replace. Did you mean replace? Yes, I did mean replace. Let's see what we get here, man. If you... Okay, we got 1. That's what we're looking for. 1. What do we get here is the... Okay, we're looking good here. So now what we want to do is we want let A and B be the 2 results from applying the operation to num independently. Turn the max difference between A and B. This is literally the same question as yesterday. I feel like I'm not... This was 1. So now do we want to just return... Okay, we want to return integer string max num minus integer string min num. Let's see what we get here. Okay, I don't think this is gonna submit. I have a feeling there's something wrong here for sure, but okay. I thought so. Okay, so what is our issue here? We get... Let's use this test case, take a look what we're looking at. So output 82,000. Num 1 2 3 4 5 6. What are we missing here, dude? I don't know. I don't know. Anyone know what the issue could be here, dude? Because I got no idea. Okay, so we get 80,000. We were expecting 82,000. So we print our string max num here. Let's print our string. Sorry, print string min num. Let's print that and take a look. So we get our original number here. We get 9, right? So as long as it doesn't equal to 9, so we would replace 9 2 3 4 5 6. That seems right. If num does not equal 0, maybe it should be 1. Because we're never going to see a 0. So maybe it should be 1. Nope. Okay, so we're getting our min num here. If num does... Oh, we're putting num, that's why. We want char. Little bugs, little errors, dude. Oh, it's still wrong. Oh my gosh. Okay, so now we're getting 81,000. One, two, three, 4 5 6. But why is this incorrect? Note that either A nor B may have any leading zeros and must not be 0. Note that neither A nor B may have any leading zeros. I don't know what I'm doing wrong here, dude. Honestly. I'm not sure what I'm missing in this problem. I'm not sure what I'm missing here. What am I missing in this problem? Replace loops don't work as intended. These loops don't hold because you're always replacing the original string, not with the updated string. That's what I thought. You only need to call replace once after you determine. Oh. So we got 2 issues. Our replace loops don't work as intended. These loops don't hold because you're always replacing the original string, not with the update string. You do replace multiple times. Only the first match matters for the digit you want to change. So what does this dot replace do? Dot replace method used to replace. Okay. I've never used this dot replace function before, so I'm kind of curious what. Let's see what we can. Okay, so we come down here, instead of looping, we can just do, well, if max num, right? Then we can do string max num is equal to string num dot replace max num with 9, right? Else we just want string max num to be equal to string num, right? Because if we can't find any instances with a 9, then it's already the max number, so we can keep it like that, right? So then we come down here and do the same for the min. We find the min here, we get rid of this shit over here, and we do, okay, if min num string max num is equal to string num dot replace string max num is equal, we'll change this to a min. String min num is equal to string num dot replace max num. We want to replace with 1 though. Change this over here. String min num is equal to string num. So the same thing, right? And then it's sort of here that we need to fix the case with the leading 0 in min case. According to the problem, you can't produce a number with leading 0. So for the min number, if it's not 1. You need to treat the first digit differently. So let's run this, see what we're looking at right now. Ooh. Replace argument 1 must be string, not none. String. Oh shit, this is min. Okay. Alright, so we're still wrong here, but what we want to do okay, we need to handle first digit carefully, so take a look at this discussion. We need to get the max and min value, have to change it and the answer is max minus min. Use brute force for all possible changes to keep the minimum and maximum values. This problem is very unclear. I 100% agree that it's totally unclear. Specifications for the problem. Almost the same as yesterday. Try the test case. So I think somehow we got to remove the leading zeros here. Man, I hate this problem, dude. I literally hated these problems yesterday as well. These are awful problems. Handle the first digit carefully. No leading zeros first. Okay, so if our first char is equal to string num, min is equal to none. If first char does not equal 1, then num is equal to first char. I can use my function. Trying to figure out what we have to do here. So, enumerate string num if I is equal to 0. char does not equal 1. Min num is equal to char, string min num. If I is greater than 0 and char does not equal 0 and char does not equal 1. So they do it a little differently here. For index and char, it enumerates string num. Okay, we want to check if I is equal to 0 and char does not equal 1, then we want to replace with it here. So we want to replace here. So we would go string where the hell, where do we create this other stuff? Okay, string min num is equal to string num dot replace with our min num. We want to replace it with 1, right? So we need to assign our min num here. So min num is equal to char. Okay. Else if I is greater than 0 and char does not equal 1, char does not equal 1. I think we have to wrap this in apostrophes, and char does not equal 0. Then we make min num is equal to char, and string min num is equal to string num dot replace min num. We want to replace it with 1. I feel like we need an else here though. Trying to think here. I think we're gonna need a break statement. Break. Let's see what this gives us here. I is not defined. Oops. Index here. Getting the same thing. What am I missing here, bro? Like, literally have no idea. What am I missing here, man? What am I? Else if case. You're replacing 1, but you should be replacing it with 0, not 1. Should be making the 0. Oh my gosh, dude, we did it, dude. It was just that. So if it's greater, we have to replace it with 0, not 1. That's literally what we missed out, man. How am I like... Sometimes it's just the little things, man. How can I be so stupid? Like, let's see if it submits first, though. Oh my gosh, dude. Cannot access local variable string min-num or... Okay, so I think... to add an if statement here. If min-num... Wait, if not min-num, then string min-num is equal to string num, because we can't change anything. That is the minimum. I think that should work. There we go, baby. There we go. Beats 100% as well. Let's go. Okay. We'll take that. Jump into something different. Jump into some graph problems or something. Let's take a look. Graph theory. What do we want to do today? Alien dictionary sort. Union find, man. I literally hate union find. Critical connections, word ladder, jump game 3. What is this one? Loads. I don't feel like a tree problem right now. Let's do a matrix graph one for now. Max area of an island. Let's check out this problem here. We have solved this before. I don't remember them solving it. April 22nd. Given n times n binary matrix and on is a group of ones representing land, connect the four directionally horizontal or vertical. You may assume all four edges of the grid are surrounded by water. The area of an island is the number of cells with the value of 1 in the island. Return the maximum area of an island in grid. If there is no island, return 0. Return the maximum area of an island. If there is no island, return 0. Turn the maximum area of an island. So we're looking for... Okay, so obviously we know that this is going to be a BFS problem. So from collections, import DQ, right? We're going to get our row. So row is equal to rows... rows is equal to grid, the length of our grid. Our cols is equal to the length of grid, there's 0 in it. Right? Then what we want to do here is we want to probably loop through each value, right? So we go for row in rows. Well, we need a range function here, range of rows. For col in range cols. We want to check, okay. We want to check, well, if our grid is a, if our grid row col is equal to a 1, right? And row col is not invisited, right? I'm going to kind of explain what I'm kind of looking at here. So the way that I think about solving this problem is obviously, as we know, I feel like this is a BFS problem. I feel like it's pretty straightforward. We're going to use a queue here, right? Ugh, I hate this color, man. So we're going to use a queue, right? We're going to loop through each value here, right? So if we see a 1, okay, we then know that this is an island, right? And that's where we're going to run our BFS function. We're going to run our BFS from from this island, right? So we landed at a 1 here, okay? We're going to call our BFS function, okay? And we're going to use, oh my gosh, dude, it's so hard to write on this, bro. It's literally insane. Like, okay, we're going to call our BFS function, right? After calling our BFS function, we're going to use a directions array, right? So we're going to have a directions array where we hold all our directions, right? So either we can go north, right? South, east, or west, right? Probably extend this out. North, south, east, or west. Okay. As we move in our BFS function, in our queue, we're gonna hold our row, right? Our call, and our count, right? And this is where we're gonna find the max island, right? As we loop through this, looping through each count, we're gonna keep track. We're gonna outside of our queue, we're gonna have a helper function using the queue, but outside of our queue, we're gonna hold a max count, right? And each time, as we discover each one, we're gonna update our max count. I feel like this is probably the brute force solution, but I think this is probably the best solution. I don't think there's anything faster that you can do. But as we discover, we're gonna update our max count, and then by the time we go through this whole queue, this whole grid, then we're going to return our max count. And I think that seems like a logical way to do it. So, if we go through here, our grid is equal to 1, and we're not in visit, then this is where we want to call our BFS function, where we want to pass in our row, our call, and our we want to pass in a count, right? Which would be 0 in this case, right? What we want to do here is we want to create a directions array outside. So in our directions array, we want to go up, down, right, and left. So inside of here, if we were to think about an XY plane, our Y would be increasing, right? So we would increase, our Y would be increasing. So to go up, we would go -1. To go down, we would go 1. To go to go right, we would increase our X, which means we would go increase our X here. And then to go left, we would increase like this, right? That left would be, going towards our 0, 0, right? We want a visited set, right, to keep track of everything we visited, right? Because if we want to run our BFS and we go to our next grid right here, we don't want to be able to go back, right? Or else it's just not going to work. Now that I think about it, that should work because we're going to keep our count locally. Okay. So we got our visited set now. Now we probably want to make our BFS function, right? So our BFS function, we're going to take in our row, our call, our visited, probably a directions array. Just let's leave it at that. Here we're going to initialize our queue, right? And then inside of our queue, we're going to initialize our starting point, which should be what we pass in, our row and our column. Here, we want to do a while queue. So while there's something inside of our queue, we want to pop, right? So let's pop our, let's actually call this RC. So we don't get confused here. Call this R, call this C. And inside of our queue, we can pop our row and our call. Row call is equal to q.popLeft. So we're popping it. And then what we want to do from here is we want to, I feel like here is probably where we want to check our count, maybe. Check count. But I'm going to leave that for now. For now, we're going to loop through. We're going to do for new row, new call. So now we're looping. So we're going to go to every single new row, new call that has 1 in it, right? So for new row, new call in directions, right? Because when we specify our directions array, we specify our up here, our down. This takes us up 1. So this is our X and our Y. Then our X, our Y, up, down, right, left, right? I got it commented here. So we loop through our for loop in our directions array, and we check, okay, we want to create a new row. So our new row would be our nr plus our original row column. So nr plus row. Our new col would be nc plus col. So nr being inside the directions array, and our row being here. Then what we want to do here is we want to do an if. We want to check our bounds, right? So it's probably the next best part, checking our bounds. So we want to check, okay, well, if grid, what would be the best thing to check here? Let's just do this. If grid, new row, new col is equal to 1. And we want to check if our new row, new col, not in visited. Now that I saw here, we want to use our count here. This is going to be our count, so we want to pop our count as well. So this would be our count. We want to initialize a max count out here. Our max count right now being 0, right? Now we can initialize it at that. We want to check, okay, well, if count is greater than max count, then let's just update our max count. I guess we can just use it using a max count is equal to max, put our max count and our count. Let's just do that for now. I think this should work. We loop through, we check if it's 1, we check if it's not in visited, and we want to check something else. Oh, we want to check our bounds, man. That's what I'm missing, our bounds. Let's do that first. So 0 is less than or equal to new row, but is less than rows. And 0 is less than or equal to new col, but is less than cols. And grid row column is equal to 1, and it's not unvisited, right? We include 0 here because in this grid we can have a 0 here, right? This is still valid, being 0 here. But obviously we don't want to go any higher than rows, right? Because rows minus 1 would be our last row that we're looking at. So what we want to do here is we want to do, okay. So if this is correct, if this comes true, this statement comes true, right? So we found one, we found our next option. It's in bounds, and it's not in visited. We can append this to our queue. Q.append. We can append our new row, a new col, and then our original count plus 1. And obviously we want to add it to our visit array too, so we can keep track of everything that we visited, right? So we add new row, new col. I believe that should be good. Check our bounds here. Probably want to return our max count. Return our max count. Let's see what we get here. 0, 0, we get 0 here. Okay, so somehow we're not updating our max count. Why are we not updating it? We append row col here. We need to add this to visited. Forgot about that. Add this to visited. We don't want to come back to the same one. Just rerun it. Still getting 0, right? So we go row col count, q.pop left. We check our max count. So if max count is equal to max count, count. Nope. We do for nr, nc, and directions. Maybe this is not updating our max count properly. Maybe we have to make this a non-local. Is that the reason? No. Maybe what we can do here, maybe we can why is this not updating our max count here? I'm not sure. Row call is equal to 1, and row call not visited. Call that BFS on it. Okay. Oh, we're not passing in proper stuff. I just realized that. Passing our visited here. We pass in our directions. Oh, geez, that's why. Geez, man, we totally messed this up. Pass in our directions. We pass in. We don't even add a count here. We need to pass in our count. I don't know how we're not getting errors here, but that's interesting. Okay. Okay, we're still getting 0. We'll call it 0. Visit.add. Up, down. I don't know. Does anyone kind of see an error here? I don't know. Like, I don't know if I'm tripping here or something, but I'm obviously doing something wrong. I believe this should update it. I don't know what I'm missing here. Why this is not updating 0. Are we getting in this loop? 0 is less than or equal to new row, but is less than rows. 0 is less than or equal to new call, but it is less than calls. Grid new rows equal to run. Oh, maybe because this is not a string here. Could that be the issue? Nope. Should this be a string? It's an integer. Maybe this should be 1 still. New row, new call. Not in visited. Yeah, I'm not sure. I don't know what my error is here. What am I missing here? I'm definitely missing something here. I don't know what it is. You're treating 1 as a string, but the grid contains integers. If grid... Okay. Is this our issue here? Can I access? Okay, there we go. So now we can't. Now we have an issue. Okay, so we can't access count. So what if we add a non-local max count here? Would that work? We get 0, but we get 4 here. Why are we getting 4? Starting point not as an area. I think we're gonna maybe instead of doing a max count, maybe we can do an area or something. Area is equal to 0. If we come down here, we do area plus or equal to 1. We get rid of our count. Could that work? Not enough values to unpack. Get rid of this count. And we return our area out of here. Return our area. From here we get x is equal to this. Then we do the max here. We do max count is equal to max count passing our area. No, sorry, our x. Oh, we can just do max count area. It's meant to be max here. We return our max count. Let's see if that works. Too many values to unpack, man. What is going on? Let's get rid of our count here. See what we get. Oh my gosh, dude. Cannot access max. Cannot access max count, dude. How? Oh, we commented it out. Whoops. Area is not defined. Whoops, I meant X. Five, 6. Well, I guess area is 1 because we've looked at this one. This is the original one, so it shouldn't be 0, it should be 1. Will this submit? There we go. Passed it. Let's go. Sweet. Another problem. Another problem solved. Got 18 out of 44 problems solved on this one now, so that's kind of goated. Nice. Let's jump into something different. Kind of getting sick of some graph problems, so let's do something different. So I said we were going to do top 100 liked. Take a look at some problems. We haven't even literally touched this once. There's some tough problems in here, but let's take a look. That's funny because we did solve N queens yesterday. I don't know why it didn't submit. Literally solved this yesterday. Did we not submit it yesterday? I don't know. I don't remember. Okay. Binary search. I don't feel like I've done a lot of binary trees recently. I feel like maybe doing a little bit of binary trees would be good. Probably a good refresher. I haven't done those in a long time. Dynamic programming, got graph problems. Rotting oranges was the first BFS problem I even looked at. Greedy, heap, linked lists, matrix, sliding window, 2 pointers. All right, let's take a look at some binary tree problems in order traversal. Let's take a look at this. I haven't solved this problem in like forever, dude. Reset this code. Cursive approach. Can the root of a binary tree return the integral traversal of its nodes? Okay. Let's call it DFS, whatever. How do we want to do this? In order traversal, what is that? That's root. So we start at the root. No, we don't. In order traversal, root left, right, I think. Is it root left, right? Shit, I don't know. In order traversal, I think it's root left, right. Visit the left subtree, recursively traverse the left subtree of the current node. Visit the root, visit the right subtree. Okay. It's been a while since I've looked at this, man. I'm a little rusty. So let's pass in our node, right? Let's look at, okay, well, we probably want to call DFS on our root, right? call DFS on the root. We want to return a list, so let's jump in over here, create a list, call DFS on it. What do we want to do? So when we cover the node, we want to do the left subtree first, right? So how would we do that recursively? Trying to remember. I have to look at a binary tree again. Is that root? Call DFS node dot left. We want to append this node first. So we need a base case, right? So if not node, you just return. Res dot append node dot val DFS node dot right. Oh, we didn't return anything. Whoops. Return res. Interesting. If not, no. DFS node dot left. Okay, yeah, that works. Okay. Well, it's a pretty straightforward problem. To do the iterative version of this, I feel like it would be a little tricky, like using a stack. Like, I don't know. I feel like it would be a little tricky doing the iterative version, but because in order traversal is a little tough. I feel like it's a little different compared to other things. Let's start the study plan. Shit. Okay. Well, for some reason, our end queens that we did yesterday didn't submit, so submit it again for our study plan. Top 100 most liked. Should we just pump out all the binary tree problems, man? Shit, it's been a while since I've done binary tree, man. Like, validate binary search tree. Let's take a look. Given the root of a binary tree, determine if it's valid binary search tree. A BST is defined as follows. The left subtree of a node contains only nodes with keys less than the node's key. The right subtree contains only nodes with keys greater than the node's key. Both left and right subtrees must also be binary search trees. So we return if it's a boolean. When did I solve this? It's been a while. April 12th, 2025. It's been at least 3 months since I've solved this. I'm trying to think what would be the best way to do this, man. I fucking hit legs this morning. My legs are killing me. The root node's value. So this is not a binary tree because we got a 4 here, and you know this 4 has to be greater than 5. Everything on the right side of the binary tree has to be greater. So this is not a valid binary search tree, but I'm trying to think here. Can we just like simply kind of iterate through this binary search tree and the left subtree, we just keep track of the parent? Is that the best way to go about this problem? I don't know. In order traversal of a valid BST, it's always a strictly increasing array. Do it for traversing and then checking using a global vector and then checking for each insertion. I'm trying to think here. So def pass in a node. Let's call our DFS function here. So if not node, we can just return. Doing an in-order traversal. Keep track of our parent maybe too. Keep track of our parent. Right, so if we were to move left, so if we call DFS node.left, node.left, our parent is node.val. Let me check here if our parent is combined trees, right subtree node, strictly increasing. So if our parent is parent is less than node.val, we can return false. Otherwise, we call this node.right. We would just return true. Node is not defined. Oh, whoops, this is meant to be root. Oh, our parent for now is none. Parent is less than node.val, return false. I'm missing something here. Maybe we don't use none. Maybe we can use like, I don't know, dude. I'm trying to think here. I don't know how I solved it. I can't remember. I mean, we're getting, the issue is we're getting a none type here, so I'm thinking maybe, I don't know, dude. I'm thinking, maybe we have to like do a low and a high here. So maybe we have to check, well, if low is less than node.val, but it's greater than high. But that's correct, right? So if we were to negate this, that work? I don't think that's how you do that in Python. Is this valid Python, dude? I don't know. So this works. This is logical operator not. Oh, I guess we can just use not. Totally forgot about that. If not, we return false, right? Otherwise, oh shit, we haven't even, whoops. DFS, want to go node.left, right? So if we go left, we do our node.val, so that would be our new node. Our low would be low, and our high would be our node.val. And I think it would be the other way around here, so it would be node.val high, you return true. But instead, when we pass in a null here, we do our low being float infinity floats infinity. We pass in. How do we do negative float infinity? Is it like this? I think it is. I don't even know. Negative float infinity represents negative infinity in Python. Okay. Hi buddy, how's it going? I think I am same as you. What do you mean by that, Dibato? I don't know. Are you kind of doing the same thing, just like kind of grinding and doing leak code, or? Okay. So, shit. Okay, so I was right. Special floating point value. Okay. So that looks good. We want to return that. So let's take a look. This gives us 2 on 3. We get true. I guess we don't. I don't think we really need to properly return true. I guess we can go return. Maybe not, dude. I don't know. Do we have to wrap this in parentheses maybe or something? Nope. Output is null. I think this is right though. I do think I'm kind of doing it correctly, but I'm not really 100% sure. 34% acceptance rate, dude. What? That's crazy, dude. How is this so low? If not node, this must be a tough problem. DFS. Bro. It's gonna be 0, so we're right. It should be a logical and. Hi, I'm missing something here, dude. I don't know what it is, bro. Float inf. Root float inf. Am I doing the right thing? Okay, low, high. It says in the problem, left subtree contains only nodes of keys less than the node, greater than the node's key. Both the left and right subtree must also be binary search trees. Okay, this is kind of like a hardcore theory problem, I feel like, but I don't know. I don't know what my issue is here. What am I doing wrong? I don't know, dude. Please help me. Bro. No way that's my issue. I have to return true here. Dude, I cannot believe that was my issue, bro. But why would we return true if not node? Why would we return true? I don't know. I just thought we would... Oh, we're never returning true in the first place. Oh my gosh, dude. That was my issue. That's crazy, dude. So because we were just simply returning here, we weren't actually returning true, so this wasn't actually becoming valid, or that's why we were getting the null when we were returning it. I don't know how I didn't see that, but alright, well, cool. Oh, well, it submit though. Oh, it did. I don't know how that's a 35% acceptance right there. That's kind of crazy to me, but is valid helper node, right? Because that was the way to think about it. It was to think about we need to keep track of our high and our low using parent values. I originally just thought it would be the parent, but you have to keep track of everything, so that's really interesting. Okay, let's jump into another one. We'll do one more binary search tree problem. Let's do level order traversal. I feel like it's been a while since we've applied some BFS on a tree. Given the root of a tree, return the level order traversal of its node values, i.e. left, right. So I obviously know that this is a BFS problem just because it literally says a level order traversal. We know that breadth-first search traverses by levels. DFS traverses, you know, straight down, picks a path and goes straight down. That's my favorite problem, BFS problems. I do love them. I have not implemented a BFS though in a little while. Hang on. It's been a while since I've implemented a BFS problem, so but let's do it from collections. A BFS problem for a binary search tree problem. We import our queue. What do we want to do here? We want to create our queue, right? So queue is equal to DQ. Whoops. We want to append our node, right? So then we go while queue. We want to pop, right? So let's do queue.pop left. Okay, we search. What do we want to do here, right? So I feel like we want to append by level, right? So here we'd have to take the length of our queue. So let's do the length. Actually, let's do the length is equal to the length of queue, right? So we know how much to loop, right? Then we go for something in range length, right? We can how do we do this? For something in range length, don't feel like we have to keep track of the index here, so we can just use that blank. But I don't know what this blank is even called in Python, dude, to be honest. I never even... What is this called? There's a name and we want to signal the person reading our code that we don't actually care about. Oh, okay. Alright. Okay. Yeah, so I don't think we really need the index. So for something in range length, we want to what do we want to do here? Do we want to append? Man, it's been a while since I've done this. How do we go by level? So, man, I'm trying to remember, dude. Trying to think about this. Shit, man. I can. So obviously each node can have 2 children, right? So we would go. We've popped our child, so we would go. Okay, well, if no dot left, q dot append no dot left. So then we avoid our null error here. So if no dot right, we want a q dot append no dot right. So we want like a. Okay, so we're doing it by level here. So we want a res, right? So let's create our res array. Q dot append no dot left. What we want to do here is we want to go, okay. Instead of appending here, I think we got to pop it inside of our 4. Instead, we pop our node. We create an array in here, right? And then we append node to our array. So we go cur.append node.val. We append its children. We exit our 4, and then we append res.append cur, right? I think that logic is right. Let's return our res. I think that works. Local variable node cannot access it. This has to be root. There's no attribute val. I think we have to do if not root. We would just return an empty array here. I think that's why we're getting that error. There we go. Cool, man. Thought I wasn't going to be able to solve that for a second. I was getting a little scared. I was literally just like, I love BFS problems, and I couldn't even solve a basic binary tree level auto traversal. Let's jump out of binary trees. We looked at graphs today. Greedy problems, hashing. I want to do something I haven't done. LIU cache. Merge case order lists. It's been a while since we've done a sliding window problem. Honestly, it's been a long time. Probably should do one. Let's just jump into like a random hashing problem. Let's take a look at group anagrams. I mean, we've done this before. It's been a while. Take a look at it again. Then we'll jump into like a hard problem that we haven't done. Probably the sliding window one. It's been a while, man, since I've looked at a sliding window problem. I think it's been at least 3 or 4 months. Like, okay, so given an array of strings, group the anagrams together, you can return the answer in any order. Okay, so let's see when I solved this. When did I do this? April 11th, a couple months ago. What is it? June 14th or something? June 15th. Given an array of strings, group the anagrams together, you can return the answer in any order. So we have our strings here. We wanna. There is no string in the strings that can be rearranged to form that. Nat 10 or anagrams, they can be rearranged to form each other. Okay. So obviously, I feel like we want to create a dictionary, right? So we can do that. What do we want to do here? So trying to think. We're given strings. I think that the way we want to solve this is we want to sort it. So if we would go strings.sort, now strings, I think that just sorts it by eat, bat, eat, net, 10, eat. So I think we have to actually sort the letter itself. So I guess we can get a little bit of a drawing up here. Take a look at how we kind of want to approach this problem. I need to think about it because I'm honestly not sure. But so if we would create a dictionary, right? Oh man, it's so hard to draw on this, dude. We create a dictionary, right? Put our problems in here. Our key value pairs, you know, looking solid. So I'm trying to think here. If we were to loop through this, right? If we loop through each value here, all right, each input in this string, we solve it. I think we sort it, right? Okay, so we sort the string. We loop. We use a for. Okay. For loop. Loop through each value here. We sort this string here, so it gets sorted, so it would be AET, right? So we're just looking at a test value here. I'm going to switch this color, man. This color sucks, dude. Let's go orange. Okay. Right, so we sort eat. So eat would be AET, right? Then we use our dictionary, right? And we go we have AET, and we would check, is AET inside of this dictionary? If not, we make it itself, right? So we would create a key value pair, right? And we do AET. Okay, and then we put in our actual eat, right? We would loop again, and we go to T. T would be AET as well. So yeah, so we would add T in here, right? And then we would go, okay, tan. So tan would be A, B, C, D, F, G, H, I, J, K, L, M, N, O, P, Q. Okay, so A-N-T, I think. A-N-T, yeah, because T would be lost, so we would get ant. Right? So then we would put tan over here. Oh my gosh, dude, how did I do that? Put tan over here. We get 8, which would be AET, so 8 would go over here because it's in our thing. Then we would get nat, which would be ant as well. So the nat would come over here. And then we would get bat, which would be ABT. So we would get ABT. And we would get bat. There we go. So I think that's the way that we solve it. Gosh. Ow. But we make this into, we also make these arrays too, right? So these would be arrays here. So then we can simply loop through our values and just append it to our. So that is correct, right? So we have bat, nat and tan, 8, eat, and t. So if we look at our you return the answer in any order, right? So I feel like that's the way that we got to approach the problem. We got to think about it like this, right? So now if we come to the solution to code it up, what we want to do is you want to go, okay, well, for I in range, do we need our index? I don't think so. For I in strings, we can go, let's just keep it at I. We can sort our I, so we would do I dot sort. Let's just print out I just to make sure this is sorting the way that we want to. String has no attributes sort. Can we do like, do we have to convert it to a list? Is that going to be our issue here? I feel like this is kind of odd to like convert it like this, but et nat10. Okay, so I guess we're gonna have to convert it, and then we would go, okay, well, if I not in my dictionary, we make let's do sorted I is equal to this. If sorted I not in my dictionary, then we were to append it. We append it here, right? So we would go _, dictionary dot append. Sorry, my dictionary sorted I is equal to this, right? Then I think we can just implement it like this. We can put in I. Else, we would do _, dictionary sorted I dot append. We append our I. Let's print our dictionary here. Print my dictionary. So what we're looking at here. None. Why we get a none here? Doing something wrong here. If sorted I not in my dictionary, then _, dictionary sorted I. Dot append I. Oh, we need to make this back into a string. I think that's why. String sorted I. We need to cast this into a string. String sorted I. We would have run this. See what this gives us here. Non-bat. Dude, what is happening here? Sorted I not in my dictionary. Sorted I, we make it equal to this. And we append I. I is already a string. Print sorted I. It's none. List I dot sort. So that doesn't work. Okay. How we make this? Maybe we have to do list I. Sorted I dot sort. Maybe it has to be separate. I don't know. If string sorted I. God, we're just casting everything, dude. This is crazy. Okay. Yo, what's up, Web Study? How you doing, bro? Web Study. How's your day been, bro? Appreciate you jumping in the stream. Okay, so AET eat and tan bat. So really this is what we want. E10. Yo, what's up, Yogesh Kumar, dude? How you doing, man? Appreciate you jumping in the stream as well. How both you guys doing, dude? Okay, so I think that should be good. I know this kind of looks a little odd here with the way this looks like it's a list as our key, but hey, like if it works, it works. So I don't know. Let's see. Now if we were to loop, if we loop through for value in index.values. Sorry, in my dic.values, my dictionary.values. Then we would do res.append value. We return our res. See what that gives us here. Res is not defined. Oh, didn't define a res array. Define our res array over here. There we go. I think this is going to be a pretty slow solution. I hope. Yeah, definitely a much faster way to do it. I feel like I did kind of like this kind of a stupid way of doing it. I'm just constantly casting variables and stuff. I don't feel like that's a good way to do it, but let's take a look at how I did it last time. A little faster last time. I did it kind of the same way. I casted here, sorted it. Then I joined it into a string. Checked if it's in the dictionary. If it's not, appended the word, else. Yeah, I did the same way. I guess it's the same thing, but I guess mine just looks a little all over the place. Oh. Let's jump into, let's do something different. Let's, should we reverse a linked list, man? Classic problem, dude. I don't know. I feel like I haven't reversed a linked list in forever. Maybe I forgot how to reverse a linked list. Yeah, screw it. We'll do one. We'll reverse the linked list. Right, let's see how long it's been. March 19th. I haven't reversed a linked list in 3 months, dude. Pretty much. So, okay. Reversing a linked list. Okay, so I haven't done a linked list problem in a long time. Okay, so while cur does not equal none. So the way that we want to do this from memory, right? I'm going to refresh myself too as I kind of explain this. When you're reversing a linked list, and I just realized it's going to be so hard to draw. We go. Okay, so we go 1. Actually, let's do our prev. Right now we have our prev, right? So our prev is here. It's not linked at all, right? We have our 1. I'm gonna try and draw this like really nice for everyone, like so everyone can see it properly. 2, 3, 4, 5. Right? So this is what our currently what our linked list looks like, right? To reverse the linked list, we're gonna need 3 pointers here, right? We're gonna need a next pointer, we're gonna need a current pointer, and we're gonna need yeah, a reverse pointer, sorry, a current pointer, a next pointer, and a previous pointer, right? So we've initialized our previous pointer over here, right? So we've got previous equal to none, right? What we want to do here is our cur is currently here, right? So we have our cur is pointing here, right? What we want to do is when we think about reversing a linked list, what we want to do is we actually want to reverse our links here, right? So this is the goal. Every time I think about a linked list problem, I think about, like, I feel like a beginner coming into this problem would probably think, okay, like, how do maybe to reverse linked list, we do it the same way, maybe in like an array or something. I don't know. Like, instead we loop through each number, we somehow change it, manipulate it or whatever, and keep moving, right? But instead, like when we think about linked lists, we think about the places in memory, right? So we have to reverse this link, right? This is the whole goal, is reversing this link, right? And making it go this way, right? Reversing this link, making it go this way, reversing this link, making it go this way, reversing this link, making it go this way, right? And then eventually, I think we're going to return our prev here, because our prev pointer is eventually going to be right here, right? So our cur will be here, and our next will probably be somewhere over here as well, right? Probably in front of our cur. Oh, actually no, it can't really go anywhere, so probably the same area as our cur, right? So let's get rid of all this. Okay. So we're here. So now what we want to do here is we want to initialize our next pointer, right? So we'd initialize our next pointer over here, okay? Right? Pointing at this one. So I think that's the first thing that we do here in this while loop, right? We'd initialize our next pointer. So we would do next is equal to code.next, right? So that's what we did. We initialized our next pointer here. Now what we want to do is we want to make I think we want to break this link. So we do code.next. Or will we do previous is equal to cur? And it's been a while for me too, so I know down here we're going to return previous. Like next is equal to code.next. We do maybe code.next is equal to previous, I think. Code.next is equal to previous. So now we're going to change color here. So now we've broke this link, right? And I believe this is now pointing here. Okay. Do we have a rubber here, dude? Oh, that did not work. Isn't this an array zone, dude? What the hell? Okay, alright, whatever. So we got rid of this value, and we move this link here. So now what we got to do is we got to move this prev and bring prev here, right? So we make prev is equal to cur. What we got? Yes, now you can make prev go to next one, so in the next iteration we'll catch up. Yeah, I appreciate that. I think that's what I'm gonna do here. Appreciate that, Hansa. So I think we make prev is equal to cur here, so then prev now goes here, right? And then we make cur is equal to next, right? So we move our cur as well. So then our cur will go here, right? Cur is equal to next. And then we go back to the next iteration, our loop here, right? So now I'll switch colors so we can do the next iteration. We'll go to like, man, I wish these colors were like brighter or something, dude. Like, so now we do the same thing, right? We'd move our next pointer. Why do I have a black, bro? What is going on? Let's do green. Right, so we remove our next. We make next over here. Then code.next. So we break this link, make this one go here. Our prev is here. We move our prev here. And then we move our cur over here. Right? And then we go into our next iteration, do the same thing. Right? So then we change the blue here. We'd move this. Our next would go over here. And do the same thing over and over again. I'm sure you guys can probably see that. And eventually we come over here. And our prev Oh my gosh, dude. Whoops. Our prev pointer would be sitting here, and we can return prev because everything's going to be pointing this way, right? Each pointer will be pointing this way. So I believe this should run, hopefully. There we go. Yeah. So we got it right. There we go. Make cur is equal to next after breaking the link. We can take 2 pointers, current and prev. Yeah, I think I did that. So I appreciate you guys for the help. Just kind of need to get refreshed, man. I've solved this problem before. It's been a while, you know. Gotta refresh myself. So I feel like it's important coming back to those problems that you haven't really looked at. So, but yeah, let's jump to something different. Let's take a look at this sliding window problem. I haven't really looked at it before. Okay, given two strings S and T of lengths M and N respectively, return the minimum window substring of S such that every character in T, including duplicates, is included in the window. Given two strings S and T of lengths M and N respectively. Okay. Return the minimum window substring of S such that every character in T, including duplicates, is included in the window. If there is no such substring, return the empty string. The test cases will be generated that the answer is unique. So in this case here, we're at B here, right? So we're looking at B. We got our output is bank. How do we get that? Okay, so A is included here, so we can get rid of A. Then we got B, and then we got C. Alright, so that would be one, but obviously that's not the longest one. We return bank here, because bank is the... So we got to think about this problem. It's been a while since I've done a sliding window problem too, so this will be interesting. Should find an algorithm that runs in O of n plus n time. It's got a 45% acceptance rate as well. Wow. Trying to think about the overall how we should start. So maybe we can get on the drawing board and think about it. Get rid of all this bullshit over here. Okay. Give it two strings S and T. So we got to think about it. So how are we going to keep track of the minimum window, right? So I'm thinking pretty much the question is we're looking for T inside of S, right? But the minimum length of T inside of S. So that means we could include other values too. But how can we know that we have included everything in A, B, and C? Well, am I a student, Vivek? I am a student, yeah. I've technically graduated, but I'm looking for a full-time role as a software engineer, software developer. So just decided to, kind of jump on the grind and do lead code. So I've been doing it for a little while now. I've been doing it for about maybe 5 months, but I've come a long way from where I started. So I'm thinking kind of maybe using a hash map to maybe keep track of these values, but what about you, bro? Are you a student, Vivek? Okay, so I'm thinking the way to start here is that we got to keep a counter of T, right? So we keep a counter of T, right? We know that we found everything inside of our window if every value inside of our counter keep going. G mindset. Thank you, bro. I appreciate that. I'm definitely trying to really put in that effort, put for that grind. But I appreciate that. Thank you. So let's do that. Let's print out T count here. Right, so we got our counter. Want to create a sliding window, right, for range and length S. Okay. When we keep track of a sliding window, we obviously need a left pointer, right? Trying to think here. If there is no such substring, return the empty string. Okay, so probably have a base case here where we go, okay, if not T, or not S, I feel like we would just return an empty string, right? We have our T count. By the way, this counter object just creates a it's like an inbuilt Python thing that counts every value for the dictionary, like what I have down here. So just a heads up. Man, I probably should have started with a warm-up sliding window problem. I feel like it kind of lost already. Clean duplicates. The entire string S is the minimum window. So we're obviously going to need a min num, right? So make this equal to the highest possible value. Vivek, me too. It's very hard to get job these days. Yeah, bro. It's definitely tough, man. It's tough out there for the new grads, but I appreciate you jumping in the stream and kind of hanging out while I figure out these problems. So appreciate that. Thank you, bro. Okay. For right and range length S. So thing is, I don't really. The only way I can kind of think about doing this problem is going through here, checking each value. We get this, right? This would be a valid string, right? But obviously we wouldn't return this because this is incorrect, right? We get this sliding window. So we go here, we see this, right? Then we want to probably come back here, move left here, and come back, right? Do this, right? Well, I guess that would be brute force in a way, so that probably wouldn't really work. But we keep going until we see a value that's in here. In this case, we found a B here that's inside. So then we work with this, see what we get. Okay, then we get our A and our C. This would be a valid string, right? Then we come back, move our next value, go through the whole string again until we see a value that kind of works. 0, D, E, and we see B. Okay, B. We go from here, do this, go from here. Doesn't work. Go from here. That doesn't, and then go from here. Doesn't work. Finishes. But is that considered sliding window? I don't know, dude. I feel like that's kind of brute force. Yeah, I think I'm going to leave this for now. I think I want to go into something that I feel like I need a warm up sliding window, you know, before we jump into a hard. I haven't done a sliding window in a while, so let's do something a little a little more low key, a little more chill. Find the length of the longest substring without duplicate characters. Okay. Given a string S, find the longest substring without duplicate characters. Okay, so we keep going. ABC. We see a duplicate here. BCA. BCB. ABC with a length of 3. Okay, so if we do a sliding window here, we go left is equal to 0. Right in range length S. Okay, probably duplicate characters. So probably, I feel like we need a dictionary. We loop through and we check, okay, well, if we increase our right, so we would go, well, y_score dictionary right is equal to, okay, so we check, okay, well, if -score dictionary right, okay, if right, no, sorry, we do if right, minimum length would be equal to the length of the string t. Appreciate that, bro. I don't know. I don't know if if you're kind of referring to the old one, the hard problem, but I'm gonna do this one for now. I've done sliding window problems before. It's just been a while. Almost 3 a.m. here. Just wanted to say all the best before I doze off. Appreciate that, Omar. Omkar. Thank you for stopping by, dude. Appreciate the love, dude. Thank you. If left not in, sorry, not why am I doing left? If right not in my dictionary, then we want to do -score dictionary right is equal to 1. Else, if it is, is equal to 1. I guess we could do, probably be a while here, right? While right not in my dictionary. No, it wouldn't be a while. Well, right not in my dictionary. Characters. Feel like we're gonna need a max length as well here. For right. I think it's probably an if, actually, not a while, but if right not in my dictionary, -score dictionary right is equal to 1. Oh shit, we're gonna have to do, we're looking at the index value here, we do s right. If s right, -score dictionary s right. Right? Because if we loop through ABC, then we get an A, right? We see an A, so this is invalid, right? So we would move our left to here. And then we would keep going. So, but how would we do that? We would go, maybe it should be the other way, dude. I'm not sure. If anyone has any ideas, man, I'd appreciate the help. That's right in Dude, I'm not sure, dude. It's been so long since I've done a sliding window problem, dude. I don't even know. When did I do this, dude? It was probably forever ago. February. 4 months ago, dude. 5 months. We got Char index. Oh, bro. This is so frustrating. I feel like I should know how to solve this. Duplicate characters. ABC. You can mark we chat as visited while we iterate. I'm not sure what that means, Vivek, to be honest. I don't know what you mean by that. What do you mean you mark it as visited? I'm not really too sure what you mean by that, but if that's right. You can mark chart as visited while we iterate. What do you mean I mark it as visited? Why don't you use Linux? I do use Linux, bro. I'm using Linux Mint. I mean, you can see here. This is Linux, not Windows, but I use Linux Mint. I'm not too much of a try-hard Linux bro. You know, huge Linux bro. I just kind of got into Linux, so okay. In my dictionary. Longest substring without duplicate characters. Okay, so if it's not in my dictionary, right? Okay, hang on. I think I have an idea here. So if we do, so we go over here and we do -score dictionary. So this is where we check that it's not in there, right? If it is in there, if sWrite, wait. Okay, so if we loop through each value and we simply just add, right? We get to a value, we see a duplicate. Then we can iterate through our current. No, that won't work. That won't work either, bro. Try run an example of pseudocode first and implement. Appreciate that, man. I've been trying to think about it. ABC. ABC. Jeez, I have to make these more kind of separate. ABC. BB. So we have our pointer here. We move here. We go here. We go here. Right? Once we reach here, we know we found a duplicate. What do we do when we find a duplicate? If we somehow keep track of what we have here. So let's do okay, let's do S right. Sorry, my underscore dictionary. S right is equal to 1. Okay, so if S right not in my dictionary, we can probably delete S right, right? So we would go if S right in my dictionary, sorry, not in, if it's in my dictionary, we want to delete S right, so we would go, okay, well, we would remove it here. Would that work though? So if we have our dictionary over here, right, with our key value pairs, right now we have A, we have B, we have C, everything is 1. We get to A, we see that we have a key value pair for it. Could we simply delete this pair? I mean, I guess we're not really doing the same thing, but I guess we can kind of keep track, then this would be 1, right? So technically, no, but we would want to move our left pointer over here. Move our left pointer over here, dude. Man, I really need to work on some sliding window, dude. I haven't done it in a long time. Okay, so if S right in my dictionary, and right is greater than or equal to minus core dictionary. That's right, it's greater than or equal to left. Right minus left plus 1. Appreciate that code with PG. Minus core dictionary, that's right, greater than or equal to left. That's right. Left is equal to that's right plus or equal to 1. My max length is equal to max length right minus left plus 1. There you go, bro. There's a right minus left plus 1. I can hash map. There you go, code with PG. There's our right minus left plus 1 right there for you, bro. Thank you for that. For right, we check if S right is in our dictionary, and is this right, dude? I don't know. I feel like this is probably incorrect. Turn out max length. Minus score dictionary. There we go. Holy shit, dude, that was awful, man. Jeez, dude. I really need to work on those sliding windows, dude. That was... It's been a while. I used to love sliding window problems too. I still do. I'm just new to your channel. Are you new or only to LeetCode? Seems like you're revisiting this one after a while. Yeah, bro. Honestly, man, I mean, what I was saying, I actually really do love sliding window problems. Actually, back in the day, I did. I just haven't looked at this problem in like 5 months, 4 months. So it's been a little while. I have to refresh myself. I've been I mean, I've solved about 428 problems. So it's been a little while, but I try and do a little bit every day. I've been doing a lot of graph problems recently, dude, so it's kind of why I'm kind of rusty on, you know, some of these earlier problems. Maybe I got to kind of refresh myself a little bit, but that's why I'm kind of jumping back to some old problems. Why didn't that submit? Did I submit this, dude? What happened to you? More than me, 417. Yeah, bro. It's kind of a grind, but I just gotta refresh myself on how I did this. How did I do this over here? Whole numbers of the window. There you go. Look at this simple solution right here. I just feel like it's been a while, dude. That was kind of bad of me. I shouldn't have struggled with a problem like that, but I don't know. It's alright. You keep looking at problems, dude. Take a look at some graph theory. Maximum number of vertices to reach all nodes, dude. Oh, minimum number of vertices to reach all nodes. Okay. Given a directed to the graph with n vertices numbered from 0 to n minus 1 and an array edges from edges I from to I represents a directed edge from node to I. Find the smallest set of vertices which all nodes in the graph are reachable. It's guaranteed that a unique solution exists. Notice that you can return the vertices in any order. So what are we outputting here? We go from 0 to 3. So find the smallest set of vertices from which all nodes in the graph are reachable. It's not possible to reach all nodes from a single vertex. From 0 we can reach 0, 1, 2, 3, 5. From 3 we can reach 3, 4, 2, 5. So we output 0, 3. Okay. Trying to think here the way to solve this problem here. Obviously I know that it's a DFS problem, right? We just got to go through each node and test out each node. But I'm trying to think about how do we know that this is the node to put in here? Oh, whoops. Let's take a Google search. 557 number of vertices. I feel like there's a simple trick with this one. 1, 2. Turn the minimum dag and notice reach for. Okay, first of all, let's create an adjacency list, right? Put in our edges. Create a hash map here. We got 0, 1 here, right? We have an edge from 0 to 1. For edge in edges, if graph. I'm proud of you, bro. Keep going. Thank you, Danny. I appreciate that, man. Appreciate the love, dude. Hello there. YouTube recommends your channel again today. Thank you, Omar, bro. Appreciate it, dude. Thanks for returning and coming back, man. I'm gonna be streaming every night, so appreciate that. Instead of making the videos on my channel, I think I'm just gonna stream live. I kind of enjoy it more. I get kind of the interaction. Besides leak code, what's your major tech stack? Java, Python, JavaScript. I've done a lot of web development stuff. So I've worked a lot with Postgres, React, Node.js, things like that. So yeah, that's kind of my tech stack. I don't really. I've been learning C# too on the side. You know, so I'm not like super experienced or anything. Like I've never really had a full-time job or anything. So, you know, I feel like I don't really have a lot of experience, but I kind of have a lot of passion projects and things that I work on, and you know, just trying to add stuff to my resume. So, yeah, that's my tech stack. How do you learn how to code? It's my first year in uni. I know the basics like importing modules and if statements, but when I try to do something advanced, I rely on AI. Yeah, bro. If I was you, I feel like you gotta struggle. Movie media, you gotta struggle. I feel like that's the most important thing. So I don't really feel like there's anything wrong with maybe using AI, but just kind of using it in a right way that you're still learning and stuff like that. I feel like that's the most important thing. So you're web focused or mobile, etc. I'm probably more web focused, bro. I've done a lot of like kind of web dev projects. You can check out my website, maxbleavers.com. I mean, it's just built in React. There's nothing special about it, but yeah, I mainly just kind of. It's not like I want to be a web developer. Like I feel like it's kind of the easiest way to get started when you're kind of thinking about like full stack development. You kind of jump into web development and stuff, and that's kind of where I've got most of my projects. But you know, I just try and learn. I mean, learning C#, trying to learn .NET development, and do some different stuff. So, yeah, that's the goal. But and then doing leak code too. So, I feel like it's important to have a good foundation on data structures and algorithms and stuff. So, but yeah, appreciate all those comments, guys. So, I'd solve these in Java. Yeah, I actually started solving these in Java at first, but I kind of switched to Python just because of I just feel like it's a little easier to code in Python, especially like you know, in an interview setting. I feel like, you know, for me, thinking through Python is probably the best. I've already graduated code with PG. I've already graduated, bro. So I'm looking for a job right now. Do you have any other job, part time or full time? Yeah, I'm currently interning somewhere. Just somewhere local where I'm at. Are you gonna graduate? Yeah, so I answered that. I already graduated. I'm actually a teaching assistant at the university here, so in my opinion, if you're using AI to think instead of doing it, you won't learn anything. Yeah, that's exactly right, Omar. I 100% guarantee. I 100% agree with that, bro. I definitely feel like you got to struggle a little bit movie media to learn. So it's the most important thing. Let's jump back into this. So let's do, okay, so for edge and edges, AB is equal to edge if graph A not in, sorry, if A not in graph, we do graph A is equal to B. Oh, sorry, graph A is equal to this. If B not in graph B is equal to this. We would do graph A dot append B. Probably make a little helper function here and return our graph. So you graduated from a CS degree? Yes, I did, bro. I did graduate from a CS degree. I went to Eastern Illinois. I played tennis there, and I'm originally from Australia, so I got a scholarship and went and played tennis over there and studied CS. So that was really fun. Some of the best years of my life. It was really fun. So, okay, let's graph is equal to adjacency list graph. Let's print our graph. Oh, passing the wrong thing. We want edges here. Yeah, I learned Visual Basic and UE5 blueprints, but it's been a struggle. I'm working on a project, but relying on AI. It's an AI video editor, and it has TypeScript, JS, HTML, CSS, Python, a lot of AI models. That's cool, man. Sounds like a cool project, bro. I've only worked on basic stuff, if it makes you feel any better. I've made basic CRUD apps and stuff with, you know, a database. What else have I done? Worked with APIs. I've built chatbots. I've, you know, but I've never like really worked on like a. I feel like what's important on a resume is like kind of working on something that kind of solves a problem. Oh shit, my bad, Mom. I gotta fix that, dude. Let me take a look at that. I didn't know. Maybe I have to edit the. What are you talking about, bro? I mean, I feel like it's mine's working, so I don't know. I don't know why yours isn't working, but it's working on my website. But yeah, this is my website. This is what I built. I built it in React. It's pretty simple and pretty straightforward. One thing I need to work on is these. You can see here it moves, and this kind of annoys me a little bit. So I gotta fix that. But just whenever I got some time. But yeah, I've gone back to what I've been working on. Yeah, basic CRUD apps I've built. Man, just a bunch of random stuff, you know, just to learn. So, literally anything you can think of, dude. Like, I've worked with like football data, like using a public football data API. You know, done some stuff with that. Movie ranking thing. I've done a note-taking list. I've done a weather app. I've done just chatbots. I'm working on a project at work with their help desk API, using a chatbot to kind of build off the data that they have in their API. So that's pretty fun. In there to build the chatbot off to learn from its data, internal company data. So that's fun. So I've worked on a bunch of small things. So, but yeah, it's kind of a grind. Just keep working on stuff, man, and just I feel like social media is kind of also what like gets you down a little bit. You know, it's tough like seeing all those like cracked people out there, and you know, they're working on cool stuff, or have like building a startup or doing all this crazy shit. So like, I just try to Oh, okay. I know what you're talking about. Ah, okay. Yeah, I'll fix that. Um, Appreciate that, bro. I I didn't double check that, so I'll fix that tonight. So, um, yeah, movie. It just takes more. It just takes practice, bro. Don't want to be a vibe coder either. Yeah, I mean, you got to think about like back in the day, like before like AI, like how people were looking up how to do these things. It's not really necessarily that you know you need to be able to know how to code it without off the top of your head. I feel like not many people. I feel like pretty much no one knows how to do that. Like if I'm like, oh, okay, like how do I, if I'm building something in Java, or something like C sharp, and I'm like, oh shit, I kind of forgot how to make a function in C sharp. Like I'm gonna look that up, and probably most likely I'm gonna use GPT or something, like, because it's just, or just type on Google like, oh, how do I make a function in C sharp, and it's gonna give me some stuff, and that's kind of how you do it. I so back in the day, people were just Googling and using Stack Overflow all the time, and doing all that stuff. So I don't really feel like there's anything there's anything wrong with using AI. It's just like using it in the right way. Yeah, you don't really want to be a vibe coder, like kind of just building the app, tell it to build it, whatever. But you need that struggle. That's kind of how you get better, just from the struggle. And that's how you learn. I feel like that's how you learn anything. If you're learning how to ride a bike, you're probably gonna smash into the fence like multiple times because you don't know how to control the bike. But as you keep going, you learn. It's kind of like how you do anything. It's just like you just keep doing it and just keep being consistent, and you'll get better, bro. I mean, there's no way that you can't. So, okay. So, what are we looking at here? We got. Let's print this again. See what we're looking at. Okay, so this is. Graph A is equal to this. B not in graph. Graph B is equal to this. Graph A dot append B. I don't know why this is not. Why is this not going through everything? Why is this adjacency list not working here, dude? I don't understand. What is wrong with this code, dude? For edge and edges, AB is equal to edge. If A not in graph, graph A is this. B not on graph, graph A is this. Graph A dot append B, turn graph. Oh my gosh, because it's inside the for loop. See, I get stupid shit like this that happens when I'm there you go. Okay. Okay. So pretty much the way that we want to solve this problem, find the smallest set of vertices from which all nodes in the graph are reachable. So return is missing though. I got the return here, bro. I know we're not returning anything. I have to build the DFS function now. I'm just trying to kind of figure out how to kind of approach this, but so we're looking at a directed oscillograph. Let me look at this again. Directed oscillograph. The graph of all edges have a direction directed and when no cycles exist. In simple terms, a diagram where arrows and relationships, you can follow the arrow where you started. Oh, whoops. So here we return 0, 3, but we have an 2, 5. From 3 we can reach 3, 4, 2, 5. So we output 0 to 3. We're at 0 and 3. Example 2. Trying to think about this. How do we solve this, dude? Hint 1. A node that does not have an incoming edge can only be reached by itself. We only have to count the number of nodes with 0 incoming edges. Count the nodes with 0 incoming edges. So maybe we don't even need an adjacency list for this. If we're counting the nodes with 0 incoming edges, zero, 3. Maybe we don't even need an adjacency list. We don't even need to run a DFS. I'm just going to keep this for now, but I feel like if we just go 4... What do we got in edges here? 4 incoming edge, outgoing edge, in edges. I feel like we just use a set or something. We do like hashy is equal to set. Then we would go let's see what we're looking here. We print our hashy here. 1, 2, 4, 5. So whatever one that we're missing here, we're missing 0 and 3. So if we go 4i, we do a res here. And we go, okay, so for I in res, for I in range length, I in range length n. Oh, perfect. They give us a range length n minus 1, right? We do a minus 1 here. Then we go if I not in hashy, res dot append I. If this works, this is so funny. Return res. Has no length. Oh, sorry. N minus 1. N minus 1. No way. Dude, that's such a funny problem, bro. Like, oh, no. I'm missing something. Wrong answer. Shit, maybe, do we just want n then? There There we go. Okay, I thought it was n minus 1, but there you go. Wow, I cannot believe that was a problem right there. That was interesting. All right, we're probably gonna do one more problem. Because I'm getting kind of tired jumping through all these problems. Let's take a look. Something I haven't done in a little while. Let's do. It's on a linked list problem today. Sliding window. Do a stack problem, dude. Min stack. Oh no, this is a design one. I don't want to do a design one. Large rectangle, histogram, valid parentheses. Take a look at daily temperatures then. Classic problem. Should I do something different? Next permutation. Not really. I don't know, dude. What should we do? I don't know what to do. I think I might have to reset this one. Nope. Okay. Let's do this one. Decoded string. We'll do a stack problem. I feel like it's been a while since we've done a stack too. Given an encoded string returns decoded string. The encoding rule is k encoded string where encoded string inside the square brackets being repeated exactly k times. Note that k is guaranteed to be a positive integer. You may assume that the input string is always valid. There are no extra white spaces. Square brackets are well formed. Furthermore, you may assume that the original data does not contain any digits and that digits are only for those repeat numbers, k. For example, there will not be an input like 3a or 24. Linked list problem. Code with PG. Okay. We'll do a linked list problem. Why not? Which one, bro? What do you think? I don't know. You have an swap nodes and pairs. I don't know, we'll do this one. Remove nth node from the end of a list. Then have a linked list, remove the nth node from the end of the list and return its head. Okay. So I'm thinking here, how do we want to solve this? Let's do. I know this is probably going to be a fast and slow pointer problem, right? Because I know that's a typical pattern for these sort of problems. What we want to do here is we probably want to loop through. Let's make a curve pointer. We'll do while curl does not equal none. What we want to do here is we want to figure out, given the head of a linked list, remove the nth node from the end of the list and return its head. So if we keep going and we maintain a pointer, so let's say we'll do cur2 is equal to head.next, right? We can keep looping, right? So we do, okay, well, starting from here, we have a 1 here. Oh, whoops. We got a 1. We go to a 2. We go to a 3. We go to a 4. Oh, whoops. 4. Oh, man. I did too much drawing, dude. Need to make this smaller so I can get it on the page. 1, 2, 3, 4, 5. Okay. So we have our pointers here. Let's do a blue here or something. We have our curve pointer currently, that's right here. We have our curve 2 pointer, which is over here. Okay. So I think the way that we want to do this is we want to keep looping cur through these nodes, right? And once cur2.next, right, is pointing at none, okay, I think our cur will be over here as well, and our cur2 will be here, right? So therefore, we find the number to remove, right? So we remove this number. Like we'll have the value that we want to remove, right? We can have this cur. Which I think is the first step in this algorithm. Right, we have our cur here, and then our cur2 is here, which is probably good. And then we need to find a way to get our previous here. So maybe we can do three. I was saying 3 pointers maybe, but prev is equal to none. Prev.next is equal to cur. Right, we make this connection here. Well, cur does not equal none. We do, sorry, well, cur2.next does not equal null. We would do cur is equal to cur.next. Cur2 is equal to cur.next. Let's have a look where we are here. I think we can use a .val here, actually, but .val. Cur is not defined. Whoops. Not associated with a value. Oh, whoops. Need to make this down here a little more. Okay. Let's leave that for now. On type is no attribute next. Why does this not like it, dude? Trying to think here. Has no attribute next. Maybe we have to actually create a new list node. Use slow and fast as you mentioned above, and think how would you move first, either by slow or fast. Appreciate that, bro. Let's do dummy is equal to list node. Dummy fast is equal to dummy. Create this list node. I believe we put a head in here, right? How does this work in Python? I don't remember. This node. Python. Wait, I think I have it up here. Man. While what's the way to do this here? We go through this, right? So wait, hang on. Okay, so maybe we need to give this an initial value, right? So we give this initial value of 0 in head, right? We move this. So this is the node that we want to delete here, right? We want to delete this value here. Okay. Right now, we have our new list node that we created here, our dummy node here. Over here. With a value of 0. With its head pointing here, right? And then we have our fast here. Right, and our slow here. Okay, so fast is pointing over here as well. Our slow is pointing over here as well. So what we want to do here is we want to move our fast all the way here. So let's do while fast.next does not equal none, fast is equal to fast.next. Right? So now we move our fast. Move our fast is sitting over here, right? Oh my gosh, dude. Right before the node that we want to remove. Now if we move our our slow, we get our slow to point here. And we get our prev. Get a prev to come here. And we can make our prev.next equal to fast. I think that's the way we can remove this link. Make our prev.next equal to this one over here. So I think that's the idea. While slow.next does not equal... Can you do this? While slow.next does not equal fast. Is that... Okay. Maybe that works. I don't know. But now we gotta move the prev as well. Maybe we can just do while slow.next.next does not equal fast. Let's print out slow and print out fast. Where are we at here? We're at 4 and 5. So maybe we want our prev over here. We need a prev. Prev is equal to prev.next. Let's print out prev. That should, hopefully this moves up prev as well. Sup, got a job? No, bro. No job yet. Non-type object has no attribute next. What's your tech stack? What do you work with? Python, Java, JavaScript, React, Postgres, SQL. Also, can you increase your mic's volume a bit? It's quite low. Shit, my bad, bro. Is that better a little bit? Sorry about that, dude. I don't know if you heard me, but it's yeah, Python, Java, JavaScript, React, Postgres, Node.js. I've done a lot of web development stuff. Just recently graduated, looking for a job. So that's the goal. Doing some leak code. Don't think I have a lot of experience yet. I've done a few internships as well. You made any projects or some shit? Yeah, dude. I've done a few web development projects. I got a portfolio website. Done multiple different CRUD applications. I've never really built something like really meaningful, like a full. The market is tough, by the way, bruv. Best thing you can do right now is get someone to give you a referral. Yeah. No, I agree, dude. It's definitely tough. It's tough for new grads. That's what I'm trying to do, dude. So, trying to network hard and do some leak code, do some projects, and kind of hope for the best. I'm pretty confident I'll find something, but hopefully something cool and something nice to be really good. So, but yeah, what about you, bro? What's your stack and what are you doing? Do you have a job right now, or? So what should be next? I do security stuff. Yeah, dude, did you masters in CS and you did bachelor's already? Is it like that? I'm currently a master's student, yeah, but I haven't finished. But I have graduated, so I'm gonna be looking for a job this fall. Yeah, dude, you will for sure. I do security stuff. That's cool, man. That sounds really fun, dude. It's definitely a grind, dude. Everything, everything in software is a grind for sure. I have a job, one I didn't even apply at all. Actually, I was teaching someone reverse engineering in a Discord, and some guy randomly asked about my skills, etc., and resume. Then, you know, interviews happen. I got the role on Gen first. Nice, dude. Good on you, bro. I'm happy for you, dude. That sounds great. Honestly, I'm really just looking forward to getting a actual job, like a full-time job, because you know, it just kind of sucks being poor all the time, bro. You know, you know, just having a job is nice. I feel like having something full time is nice. So, yeah. What are we looking at here? 4 and 4. Why is this preview here not? They're hiring right now a back-end engineer. Appreciate that, bro. Good company, great pay. Appreciate that, man. I mean, if you want to send it to me, I got all my socials in the description and everything. My LinkedIn's there, and you know, I got Discord on there and everything. So I love to if you send me the application, I definitely apply. Keep slow and fast both at head and dummy node may also on head. Dummy would have your actual reference, so now you can play slow and fast. You're doing already good. Thanks, bro. Sorry, I've been in and out looking at the chat. So I kind of know how to do this. Right, so I'm initializing with the 0, got the head as the next. I don't know why. Fast on next. Good company, great pay. What is going on here, dude? Man, I can never seem to sit down and do leak code. I've been programming since I was 14 or something. Have a 10-year-old Codeforces account. Never did seriously brain shut, just sucks off. Yeah, dude, it's tough, man. Definitely, it's definitely tough. I've been doing leak code for about 5-6 months now, but sometimes when I come back to old stuff that I already looked at, I just forget it, bro. It goes out the window. Like, I understand like the basics and everything, the patterns and everything, but sometimes I just forget. So let's take a look here. Passing in and steps ahead. That means you're not creating the correct distance in between fast. So. Oh shit, dude. I'm so stupid. I'm just thinking of this one problem, right? I shouldn't be using a while here. I should be using a for. Why am I using a while? In range n. Fast is equal to fast.next. That's the main thing. To reach the nth node without using it, we can't reach the nth node. Yeah. That's what I just did here. The nth node is a node that we want to delete, right? So we want to delete. In this case, is this example 1? Yeah. Fast.next, we want to move fast on next, slow is equal to slow.next. rid of this previous. What are we looking at now, dude? Gotta wait for this, man. Oh my gosh, dude. $3.5. Okay, perfect. So now we just need to do slow dot next is equal to fast. We meant to actually we need to return our dummy. Whoops. Return dummy. Dummy dot next. I need to concentrate a little bit more so I can actually do the problems, man. Like 0, 1. Got a few edge cases here. Man, I don't know what I'm missing here now, dude. Dummy, slow dummy. We go to N, right? So N being the node that we want to remove. Then we move the slow node up. Slow dot next equal to fast. Oh my gosh, there we go. Okay. Finally. Alright guys, I think I'm probably going to end the stream there. Do you do OBS contribs? I don't really know what that means, to be honest, bro. I'm using OSS contribs. Sorry, I thought you said OBS. No, I don't really know what that means, bro, to be honest. But yeah, I think I'm going to finish up the stream here, guys. I appreciate you guys watching. Thanks for all the support. Thanks for all the nice messages. I'm getting pretty exhausted. Took me a while to do that problem. So have a good night. Yeah, it's like 5 p.m. here. So have a good evening, I guess. But wherever you guys are, so have a good day or whatever it is. So Bruno Alvarez, what's up, man? You meant to be open source. Yeah. Open source contribute. Oh, OSS. Oh, okay. Do I do open source contributors? Okay. I understand. No, I don't really, no. I just work on my own stuff usually, but I probably should, but I kind of have more fun just doing my own stuff and working on my own things and you know, just doing that. So, but yeah, appreciate you guys watching. I will see you guys tomorrow. So thank you guys for the support. I'll be back live again probably this time tomorrow, probably a couple hours later, probably nighttime here. I gotta go to work and everything. So thank you guys, and I will see you guys tomorrow.